In today's video, I'm going to show you how to set up and create your own local smart home scene controller using the NSPanel. Check it out. What's going on, guys? I hope you're all doing well. In a previous video, I showed you how to flash the NSPanel with ESPHome, and this allowed you to take full local control of the device and set it up and control it all using Home Assistant. And for me, this has worked great for well over a year now, and the only real issue and gripe that I've had is the fact that if you want to customize it and change it up a little bit, then you do need to spend a bit of time using software such as the Next-Gen editor to actually customize those pages and build them. And this isn't particularly difficult, but it is a lot of work and it is very time consuming, especially if all you want to do is just add a little button to a page that when you press it, it does something. You then have to write all the code for that and design the screens and do all of those little bits. Well, thankfully, that's now going to be a thing of the past, especially if that's the kind of design that you want. A user by the name of Blackumus has been working on an NSPanel project that essentially allows you to take a Home Assistant blueprint and just fill in that blueprint using your different entities and devices, and that can then be used to actually set up and configure your NSPanel. And best of all, this requires no code. Version 3 of the NSPanel Home Assistant blueprint has just been released, and essentially it's made up of two different parts. You've got a small ESP sketch that you flash onto your device, and when you load that, that just pulls down everything that the project needs. You've then also got the Home Assistant blueprint, which, as I explained, you just simply fill that in and that actually customizes and sets up your panel. One of the main features of this project are the 4 customizable pages. Each page can contain its own header, which gives a clear indicator to actually what the page is, and the page can also contain 8 buttons. So with some quick maths, you get 32 buttons with this project, and each of those buttons can be set to one of your Home Assistant entities or devices. And to take this a step further, those buttons aren't just switches, so they can be if you want to just click it to turn something on and off, but these can also be light controls where you can actually go in and change the color temperature. You can change the color using a full color wheel. They could also be heating controls, climate controls, covers, blinds, scripts, or just plain old switches. Navigating the panel is very intuitive. You simply just swipe through the different pages to access the page that you want, or if you're on the home screen, you can make use of a simple gesture, whether that's going up, down, left or right, to quickly jump to one of the set pages. So for example, if you want to jump to page 2, you could just simply swipe up. These quick gestures are really nice, and if you make use of the panel a lot, it won't take you long to actually build up some muscle memory to actually learn which way you want to swipe the screen to just quickly jump to the thing that you want. Also, if you decide that you want to customize this thing a bit further, you do have full access to that source code. So if you want to change the design up a little bit, or you want to customize it a bit further, or maybe you want to just subtly change a few things but still keep the blueprint, then you can totally do that. So enough of the overview, let's get into what we actually need to get started with this project. For this project, we're going to need a small Phillips screwdriver, a USB TTL adapter, 5 female to male DuPont wires, and of course the NSPanel. In addition to those things, there are a couple of other things that I would recommend for this project that will just make your life a whole lot easier. The extra bits that I'd recommend are a USB extension cable, some form of mount to actually hold the panel so you can do testing and development on it, and a spudger, you know those little plastic tools that you can use to pry things open? Yeah, one of those. In this video, I'm making use of the White NSPanel. The White panel is identical to the original panel, but there are a couple of design refinements within this White panel. The first and most obvious one is the inclusion of a QR code on the back of the device. Using this QR code allows Sonoff to not have to bundle instructions within the box, so they can just cut down on the waste packaging for this product. The back plate for the White NSPanel has also been changed ever so slightly, so it's now easier to actually mount in your wall. And the final one, which is probably my favourite one, is the buttons have actually been changed, so they're a lot clickier and they just feel a lot snappier as opposed to the original panel. And that's pretty much it for the hardware. If you're not sure about some of those things, or you haven't got some of those things, I'll leave a link in the description below to some of the parts that I've used. And for the software, I'm going to be assuming that you've already got ESPHome set up and configured on your machine. If you haven't yet got ESPHome installed, you'll need to do that first, and you can do this by simply heading into your add-ons, doing a search for ESPHome, selecting it, selecting install, and then you're good to go. By default, the NS panel comes preloaded with Sonoff's eWeLink software, but we're not going to be touching that at all, so you don't need to worry about setting it up or configuring it. So if you're making use of a brand new NS panel straight out of the box, then you can go straight into flashing it with ESPHome without doing any of the initial setup stuff. If you have previously flashed your NS panel with ESPHome, then you can actually skip over this first part of the video, just because we're going to run through actually flashing ESPHome onto the device. Let's get into it then. Literally, let's get into it. On the base of the panel, you'll find a small tab which you can use to actually separate the screen from the relays. With the relays separated, you can just put those to one side, as we're not going to be messing with those. And if you flip the panel over, you'll see two small screws on either corner of the device. If you take both of these out, you'll be able to easily remove the back piece of plastic, which will expose the PCB. On the PCB, you'll find 5 exposed input pins. These pins are 3 volts, ESP-TX, ESP-RX, ground and IO0. You'll also find some exposed header pins, and these header pins give us access to 5 volts and ground. If you're still a little unsure of those pins, here's a little diagram from Blackadder which clearly states what the pins are. Now that our PCB is exposed, we can start hooking up some wires to our USB adapter, and my adapter of choice is the FT232 by DSD Tech. The last time I flashed the NS panel, I created a small little jig which basically made use of the offcut of some Raspberry Pi header pins, and I just pulled out the original pins and then just pushed my wires through that. This small piece of plastic perfectly holds all of my wires in place, and it just saves them wiggling around or moving out of place, which is something that you don't want to happen whilst you're trying to flash something. I definitely recommend trying to hold all of the wires together, and if you do decide to make use of something like that header offcut, then you should end up with 5 wires all held together like this. So let's attach the wires to our adapter, and there's no real colour convention for these wires, they're just wires that I had lying around. So here I'm attaching red to 3 volts, purple to RX, blue to TX, and green to ground. If you're also making use of the FT232, then do make sure that you're connecting it to 3 volts and not 5 volts. If you do accidentally connect it to 5 volts and you try and power the panel or flash the panel with that, you can potentially damage it and burn it out, so don't do that. You'll notice that we've got this black wire that isn't connected to our adapter, so to actually flash the device, we'll first need to put it into boot mode, and there's not a convenient button to actually do this, so to put the NS panel into boot mode, you'll need to connect the IO0 pin to a ground pin, and that's what our black wire is going to do. With my little jig here, I've got all 5 of my wires all held together, and if I look at the board, I can see the 3 volt pin, and I know that with my wires, my 3 volts is my red wire, so if I just line that up and then put all of the wires into the holes, everything will line up perfectly, and I'll know that everything is correct. As I mentioned, we're going to be using this black wire to connect to a ground pin, so if we look at this diagram, we can see that there's a ground pin on those exposed header pins, so I can simply connect this black wire to one of those pins now. And if you're following along, this is what you should now have, and if you're struggling to actually see what's going on, here's some sweeping shots of the board so you can actually see where the pins are going and what they're connected to. Taking a quick break from the hardware, let's make a start on the software, and we're going to open up ESPHome. With ESPHome opened up, we're going to choose to add a new device in the bottom right corner. We're then going to select continue, and we're going to give our device a name. I'm just going to call mine NSPanel White and click next. We then need to specify what the device type is, so in our case with the NS panel it's just an ESP32, so select ESP32 and hit next. You'll then hopefully be greeted by the configuration created page, and we can just click skip. In your list of ESP devices, you should now be able to see that new device that you just created, so find it and then just select edit. Here we can see the default configuration that you get for an ESP device, but what we're now going to need to do is to just replace all of this with the code that's available on GitHub. So you'll find a link to that in the description below, so let's go over there now. Over at GitHub, if we scroll down, we should be able to find the code that we're going to need to copy and paste in. Partway down the screen, you should see a section for code, and if you just hover above the right hand corner of that code block, you'll see a little icon appear, and if you select it, it will copy the code to your clipboard. Jumping back to ESPHome, we can just select all of the code that's currently on our device, and we can just paste our new code over the top. You'll notice in the code that we've just pasted in, it's split into 2 sections. There's this change me section and a do not change anything section. For the change me section, you'll need to enter your device name, your Wi-Fi SSID, and your Wi-Fi password. If you're making use of ESP secrets, then you can also use those for your Wi-Fi and your password. If not, you can just freely type them in between the quotes. One quick tip here to hopefully save you a little headache is your device name can't contain any special characters. So the first time I did this, my device was called NSPanel-White, and that dash caused me to not be able to actually load the full configuration onto my NSPanel. So don't include any special characters in your device name. Once you've made those changes in the Change Me block and you're happy that they're correct, you can just go ahead and press save in the top right corner. And that's literally it for the ESP sketch. That tiny bit of code is going to do all of the work. That's going to go off and fetch everything that we need. What we now need to do is to import the blueprint. You'll find a My Home Assistant link in the description below, and when you select that, it should hopefully import the blueprint into your Home Assistant. If for whatever reason this doesn't work or you don't have My Home Assistant link set up, you can just navigate to Blueprints and you can choose to import a blueprint and you can just enter the URL there. You should hopefully see the NSPanel Home Assistant blueprint pop up and you should be able to preview it. Once you're happy reading through the preview, you can go ahead and press Import Blueprint and that will bring that blueprint into your Home Assistant. You should now be able to see NSPanel configuration as an option listed in your blueprints, and to the right of it, if you just select Create Automation, you'll be able to start filling it in. The first thing that we need to fill in is the ESPHome node name, and this node name is your device's name, which you set in your ESP configuration. This field needs to be 100% correct because if you misspell it or mistype it, then the automation won't link up with your panel and your panel configuration won't work. So just double check your ESP configuration to make sure you got this one right. There's a whole bunch of different settings that you can fill in this blueprint, and whatever settings and changes you make in this blueprint will directly affect your panel. For the majority of these, I'm just going to leave them all on the default settings for the purpose of the demo. But you can play around with these and you can tweak and change them, and as you do, you'll see those directly reflect on your NSPanel. They're all nicely documented with a heading and a little description underneath them, so you've got all of the information that you need all within this little blueprint. For my weather entity, I'm going to use the default Home Assistant weather. I'm also going to set the outside temperature sensor, my indoor temperature sensor, and the humidity sensor, just so I've got a few different options to play around with. If you're making use of any heating controls or climate controls, you can also set these in here, and these will give you a couple of options that you can control with using the panel. You'll notice that with some of the settings, these are optional, so the optional ones you can just leave blank, but if they're not optional, you will need to fill them in, otherwise the configuration won't work. You can set controls for your left and right buttons on your panel, and these are the two physical buttons on the front of the panel, and you can also name them. Following on from the buttons, we've got the names for the 4 different pages. If you don't set these, they just inherit the default name of button, page, and then the number, so I would recommend just filling them in just so that you've got a bit more detail of what the page does. After this, you've got a section for each of the different pages, so there's a section for the 8 buttons that are on page 1, and with each one you get to give the button an entity or a device, and you also get to give it a name. So you can just run through these, assigning different entities and devices to the different buttons. With our blueprint now set up and ready to go, we can jump back to ESPHome for the last time and we can actually flash our device. So back at ESPHome, we're going to choose Install in the top right corner. I'm going to select to plug into this computer. Making sure our pins are all making contact with the PCB and that they're all in the correct location, we're going to plug our USB adapter into the USB extension cable and plug that into our computer. When we do this, we should see our device appear in the list of connected devices, and if we select that, the installation should start, and you should see a little preparing installation spinning wheel. This process should just take a couple of minutes, and while this is running, you do want to leave this page open, just so that it speeds up the process. If you're struggling to get your panel into boot mode and you're copying along with what I'm doing, then you can also try taking the PCB out and flashing it like that. The PCB just disconnects from the ribbon cable and then you can flash the PCB by itself and then put it all back together. I personally choose to not do this just because it saves me having to undo things and put lots of things back together, but that's just me. If you're also copying along and you find that your pins are too long, if they do stick through the board fully, then they'll actually touch the metal plate beneath it and they'll short out, and that will stop the panel going into boot mode. So one way around this, if you don't want to take the whole PCB out, is you can just stick something underneath it and lift it up ever so slightly, and that will stop your wires touching the metal plate underneath it. So I've done this with a pen or with a spudger, and it works quite well. Once the flashing completes, we should hopefully see that congratulations message, and when we see that, we can just start disconnecting everything from the panel and start putting the panel back together. We can then power the panel up and we can get started with the next step, and you've got a couple of options for powering it. You can either power it through the mains, or if you're using one of these FT232s, you can actually power it using the 5 volts, connecting it to the correct pins. I'm making use of one of Sonoff's handy little mounts and I'm powering mine through the mains, so I'm just going to connect my panel to the front of that and power it up. When the panel turns on, you'll actually see the Sonoff logo and you'll see the Sonoff eWeLink software, but don't worry, it has worked. If you head back to Home Assistant, you should hopefully see a little notification telling you that a device has been discovered, and if you click that, you should be able to see your new ESP device. If for some reason your device isn't automatically discovered, you can manually add it by choosing Add Integration and selecting ESPHome. You'll then need to manually enter the IP address of the device, so you might need to look up these settings in your router. With your discovered device, you can just go ahead and press Configure, assign it to an area, and then choose Finish. Now in your integrations underneath ESPHome, you should be able to see that new device you've added, and if you select that device, you'll be able to see all of the new controls, sensors, configurations, and diagnostics. If you play around with any of those controls or change any of the configurations, you should actually see that start changing on your NSPanel, but you'll notice that the NSPanel is still running eWeLink and it's not running our new display. So let's fix that now. To do this, if we just scroll down in the device under configuration, we'll see an option for update TFT display, and this has got a little toggle switch. So if we just turn this on, what this will do is it will start downloading and updating the TFT display, and this is actually the longest process of the whole setup. If you take a look at your NSPanel now, you should see that it's doing an update and it's downloading this new TFT display. And again, this can take a few minutes. On some of the panels it's been a lot quicker for me, but some of them have taken 10 minutes or more, so do be patient and just wait for that to finish to 100%. Once the panel finishes updating, the screen should go black and then it should immediately go blue, and you'll see the initializing please wait screen, and after a couple of seconds the panel should open up to the new display. If you did everything correctly, you should now be able to view the panel and swipe through the different screens, and any information that you entered in the blueprint should now be visible to you on the panel. And if you decide you want to change something or you want to modify something, just head back into that blueprint and make a change, and that will reflect live then on the panel. To wrap this all up then, I'm just going to run through some issues which will hopefully help some of you guys out, and I'm also going to run through some gripes that I've got with the current setup for the panel, and some features that I'd like to see added maybe in the future. My first issue is one that I actually encountered myself, and it's to do with naming the device. So in your device's name in ESPHome, if you actually include any special characters in the device's name, then the panel won't actually build, and although you'll be able to flash it, it will actually start initializing. It will just get stuck on this blue screen where it will say please wait, and I waited a long time and it never worked. And I opened up a Git issue for this, and I finally realized after actually reading through the documentation properly that it was to do with this special character, and as soon as I changed this, it just instantly worked. The next issue is more than likely going to be flashing the device. So if you've copied the way that I've done it, where you actually don't take the PCB out of the panel's housing, then you may encounter some issues where if you're not correctly touching the pins or have all the pins touching at the same time, it may just cause you some issues. Some workarounds for this are to actually just take the PCB out itself, or if you do something like I did where you put the spudger underneath the panel, that will just lift it up slightly and it will stop any of the pins making contact with that piece of metal. A couple of gripes that I've got with the current project is to do with the way that offline or unavailable devices are displayed. So currently they're not displayed, so if your devices go offline or disconnect, then the actual square tile is missing, so you just end up with lots of missing spaces. I'd much prefer it if they showed up and just had a different icon, or they just displayed in a different manner so that you knew that they were offline, as opposed to being missing entirely. The other gripe that I've had is that if you make lots of changes all at once, they don't seem to update directly on the panel, and you actually have to press where the buttons would be in order for them to appear. So for example, if you add 4 new buttons, you then actually have to touch where those buttons will be in order for them to actually appear. So the panel knows that they're there, they're just not updating on the display. My last point then is just a small improvement suggestion, and this is probably just personal to me, but I'd like it if the clock on the home screen was just made a little bit bigger. That way if you're across the room you can see it a lot easier, and I know that I could probably just modify this in the files myself, but it'd be cool if it was just a little bit bigger. And there we go guys, that's been a little look at a very simple way to actually set up and configure a local smart home controller using the NSPanel. A massive thank you to all of the guys that have worked on this project. I'm looking forward to seeing what else comes out with this project and what new features are on the way. If you enjoyed this video, then don't forget to drop me a like, and if you're not already, hit that subscribe button and ding dong the notification bell. You'll then be alerted to any future video that I do. As always, a massive thank you to these awesome dudes. These awesome dudes are my Patreons, and if you're interested in helping support my channel, which allows me to create tutorials and other things like this, then you'll find a link to my Patreon in the description below. Thank you for watching, and I'll catch you in the next one. Cheers.